Good afternoon, everyone. Today we're going to do a video on the roots of rational numbers. That means the roots of numbers that can be expressed in the form of a fraction. And so these are the three examples we're going to look at. First off, I'll remind you of one of the exponent laws that you probably were introduced to some while ago. And I'll make a note that you'll see later on, probably around grade 10, that roots of any kind can be expressed as exponents. Now, that's not important for now, but I'll just note it here that the square root of, let's say, some general number x can be written as x to the power of 1/2. And so a square root is the same as an exponent of 1/2. And likewise, a cube root of x, which we have in example 3, can be written as x to the power of 1/3. You might have seen that already, you might not have. It's not particularly important here, but it is important because it means that we can use one of the exponent laws that states that x over y all to the power of a. So when we have a fraction raised to an exponent, we can write this in a different form as x over a over y over a. And so the exponent can attach itself to both the numerator and the denominator individually. Okay, now this is going to let us simplify down the task of evaluating these square and cube roots. So let's look at example 1. First off, we have the square root of 0.25. Okay, now if you know the answer already, then you're good to go. However, if not, I recommend writing any decimal number that we're trying to evaluate the root of in the form of a fraction, because using this rule makes our job a lot easier. Now, 0.25, this might stand out to you. You might write it as 25 hundredths, because that's 25 ending in the hundredths place, or you might realize that 0.25 can be written as 1/4. Okay, I'm going to go with 1/4 just for now, and then I'm going to remind you guys of the law we just spoke about. If x over y all to the power of a can be written as x to the power of a over y to the power of a, and we've already stated that square roots and cube roots can be written as exponents, then that means that the square root of 1/4 can equivalently be written as the square root of 1 over the square root of 4. And now this becomes much easier, right? We have the square root of 1 in the numerator, which is simply 1, and we have the square root of 4 in the denominator, which is 1/2. We can leave the answer as 1/2. Since we began the question with decimals, we could also always write our answer in decimal form, right? If you're so inclined. Not necessary, but you do have that option, okay? Now, we'll use a similar strategy for example 2, just slightly trickier numbers. So we have the square root of 0.0144. So that is 144 that ends in the 4th place after the decimal, which means that's the 10,000ths place, right? 10,000 has 4 zeros. Likewise here, we're in the 4th place after the decimal, and so we're into the 10,000ths. And so I'm going to rewrite this root as the square root of 144 10,000ths, okay? And now I'll apply the same exponent law that we used to evaluate example 1. We'll write the square root of this fraction as the fraction of square roots, and so we'll have the square root of 144 in our numerator, and we'll have the square root of 10,000 in our denominator. And now we can evaluate these individually. We've known for quite some time that the square root of 144 is 12, and the square root of 100 is 10, and the square root of 10,000, we can simply have the number of zeros whenever we're evaluating the square root. And so if we have the number of zeros, we'll have 100 as the square root of 10,000. You can verify that if you really want. 100 squared does indeed produce 10,000. And so now this is our fraction. You would be asked to simplify if you're going to leave it in fractional form. And so we can divide both of these numbers by 4, and we can write our simplified fraction as 3/25. If you do want to leave your answer in decimal form, since we began in a decimal, you can of course write this as 12 hundredths or 0.12. Okay, so 2 examples done with square roots. Let's do one cube root for good measure, because cube roots can be written also as an exponent, and so we get to use the same exponent law that we used for our first 2. And so we have the cube root of 0.125, which we'll write as the cube root of 125, ending in the 3rd place after the decimal, which we know would be the thousandths place. And there we have it. And now we have the cube root of a fraction, which means we can take this cube root, which means we can take the cube root of the numerator and the denominator individually. And so we'll do so. We'll have the cube root we'll have the cube root of 125 over the cube root of 1000. And now this becomes, again, not too difficult. We evaluate the cube root of 125 as 5, and we evaluate the cube root of 1000, if you remember your cubes, as 10. And so we now have to simplify 5/10, which isn't too terrible. Dividing both numbers by 5 gives us a final value of 1/2. Or again, since we began in decimal form, of course, if we want to write 1/2 in decimal form, we get 0.5 as the cube root of 0.125. And there we have it, okay? So hopefully this ties in one of the exponent laws that you learned early on in the year into the evaluation of the roots of rational numbers. We could apply this with quartic roots, quintic roots, any amount of roots of rational numbers. So themselves, if you guys have any questions, comments, suggestions, please let me know. And requests for future videos are always appreciated, and thanks.